Let's go back to our previous material we covered on Friday. So filtration and reabsorption. So filtration, again, we're talking about the overall movement of fluids from the inside of a blood vessel toward the outside, and reabsorption, that's the opposite. So this is due to oncotic and osmotic pressure, and this is when we have negative net filtration pressure. And again, net filtration pressure is that difference between capillary hydrostatic pressure and blood colloid osmotic pressure. So near the arterial side, it's bigger, it's positive because again, capillary hydrostatic pressure and overall blood pressure is higher near the artery side and drops off toward the vein side. And when it's at the venule side, well, remember that BCOP, due to those albumins and other large blood proteins not filtering out of your blood vessels, this stays constant. But due to the drop in pressure, now we have greater BCOP than CHP, so now overall fluids are going to move back into the blood vessels. How do they get rid of the plaques? Ooh, that's a very good question, and actually it's like very cool. Like one way is you can do those stents. You can open up those, like I covered with like PCI and stents and angioplasty. That's one way of opening up these vessels again. So it's not only in the heart that you can do these stents. You can do them in theoretically any vessels. There's also drugs that are thought to help to kind of like reduce the formation of these plaques or help to dissolve these plaques, but that's actually an active area of research. Okay, so then back to our lymphatics. All right, so net filtrate, notice those numbers right here. Are they equal? So notice that the net filtration pressure, the overall pressure on the arterial side, this absolute value of this 10 millimeters mercury, well, that's our filtration. So that's why overall per day we filter about 24 liters of fluid from our vessels into our interstitial fluid. And on the venule side, well, we do reabsorb about 20.4 liters per day. So there is this inequality right here does result in an inequality here. So where does that remaining 3.6 go? So that remaining 3.6 is somewhere here, but it actually ends up going eventually into your lymphatic vessels. So this is why we need this. So the end message I'm getting at here, your overall systemic filtration that happens every day in your body, the rate of that is greater than your reabsorption, but you have to make up the difference somehow. So again, slightly more fluid leaves your blood vessels and filters out than it's reabsorbed. But if that happened and you didn't compensate for that, that means your tissues would get more and more waterlogged and your blood would lose more and more fluids over time. So the thing is that you have to move that leftover fluid back into your blood, back into your circulation, and this is where lymphatics becomes very important. So lymphatic capillaries, what do they do? Well, notice that they're running next to our capillary beds. And what we have here is our water molecules. So they're going to filter out due to capillary hydrostatic pressure, and they're also going to be reabsorbed due to BCOP, right? But notice that some water molecules, they still are left over in the interstitial fluid because again, overall, capillary net filtration pressure is greater in filtration than it is in reabsorption. But what happens is that difference, it can be brought back into these lymphatic capillaries